Okay, now this is a rather straightforward example if you rearrange the equation properly. In the first place, we do know that this is a separable equation, which would be easy enough to solve as a separable equation, right? And if you see this equation on a test and decide you'd rather do it as a separable equation, that's more than fine. You're going to have to do an integration by parts, but you have to do that a lot with separable equations. Not an integration by parts, partial fractions. Okay, so anyhow, can we rearrange this to the form of a Bernoulli equation? Well, first thing we want to do is distribute, and that should be pretty obvious. Okay? And then we can add y. That's y squared there. We can add y to both sides. And we have this, right? Okay? Now, it's Bernoulli. Can we identify the P of t and the Q of t? Remember the form, because I don't necessarily expect you to lock this in. Okay? So is it in this form? If so, what's P of t and what's Q of t? And what's M?
T is -2, Q is -1, and N is 2.
Yep. Bingo, very good. P of t is -2. Q of t is -1. And N equals 2. Okay? Okay, well, so we're going to let V equal y to the 1 minus n equals y to the -1 or 1 over y, whichever form we choose to use. Okay? So that V prime equals -y to the -2 times y prime. Y prime equals V prime negative V prime y to the -2 to the y squared, okay? And we'll note that then V equals, I'm sorry, y equals 1 over V, right? Okay, so we have this, and so this equals -V prime. I'll write it as -V prime over V squared. That's going to be relatively easy to deal with. Okay? So our equation becomes and it's a matter of taste whether you write that as reciprocal V squared or V to the -2. The equation becomes this. Okay? Our y prime is -V prime over V squared. And our -2y is negative two over V equals -y squared. Okay? Sorry, -y squared is -1 over V squared. Right? And now what we want to do is multiply by that V squared in the denominator, and we get -V prime minus 2V equals -1. There you go, it's linear. And if you do all this right, it's got to happen. Okay? If you've correctly identified the equation as Bernoulli, correctly identified your P, Q, and N, it's always going to come out where you have some function of t on the right side, no v. And you have a v here and a v prime. Now, since all these are negative, we just multiply through by -1 and we dispense with the negative signs. Okay? Note that the equation is still separable. Okay? Start separable, it's going to stay separable. I think, I haven't proven that. Seems like it needs to, but I don't want to think through that right now. Never even asked myself that question before, so it's an observation. It's, you know, you have those observations, you have time to follow up on them, you learn stuff. Okay? If you don't have time to follow up on them, you can still use this course. Now, you get this, right? So now you have what? Linear, first order, non-homogeneous. Integrating factor e to the 2t. Okay? Because your integrating factor is e to the capital P of t. Here's your little p. Capital P is an antiderivative to e to the 2t. So you get this. Your left-hand side is a derivative of e to the 2t times v, which you should always write down and verify. Okay? It seeps into your soul. And then you get out there in the ozone and you kind of haven't done one of these in a while and you know how to think it through, right? Hopefully it stays with you. So this is very straightforward. So there's no prime on that. If I catch something out of my peripheral vision, I want to write it down. You know, last night I was sitting there reading, and out of my peripheral vision, I kept seeing something moving. So I'd look where the motion was, and I couldn't see it. Look back at the book. Nothing there. Okay? Finally caught it. You know, it's a nap. But your peripheral vision picks up stuff that your focused vision doesn't. If you're trying to observe the position of a star, or see a star that's just at the limit of what you can see, you don't look right there. You look just a little away from it, and the peripheral vision catches it. Okay? You ever have that experience? You probably have. You just haven't noticed. Start noticing.
Yeah.
Okay. Just like you notice things in equations and things, right? Catch something out of your peripheral vision. Now, it's not always good, because I caught that on my peripheral vision, that prime, and then I wrote it down. Okay, so peripheral vision has. You ever seen the video of the basketball players with the moonwalking bear?
No.
I read a good article on perception last night. I won't digress any further. I'll try to get that one up and show you.
Okay.
It took me several tries to see what was really there. Okay? Because you're focused on something else. And it's kind of funny. It's kind of a famous video. Okay. Makes a big point. Okay, so anyhow, e to the 2t times v equals what? Well, this is the antiderivative of this, right? It's got to be the antiderivative of this. So there it is, right? And this should be familiar. You've done a bunch of these now. So v equals see, it's kind of too close to the E, blame it on the chalk, right? But you divide by the E to the 2t, you get the 1/2, and you get C e to the negative 2t. Okay? Now that's V. You want Y. Because Y of 0 equals 1. Now if Y of 0 equals 1, then V of 0 equals 1, because, wait a minute, let's go back and see, where's my change of variable? N equals 2, yeah. So V is 1 over Y, right? I'm not sure about that. So, and that's, if Y of 0 is 1, then V of 0 is 1. So you could solve that right now. V of 0 is 1, so C has to be 1/2, right? But that still only gives you V, so you might as well go ahead and see what Y is, okay? So Y is this, okay? Okay, well, it's still kind of a complex fraction. You got the 2 in the denominator, so we could at least multiply both sides, or numerator and denominator by 2. I get 2 over 1 plus C e to the negative 2t, C absorbing the multiplication by constant. But then I could multiply by 2e to the 2t. Okay? Well, that'd be 2. Yeah, I'm not sure there's a good point in doing that, but it's something you want to keep in mind. Right now, it looks like about 6 of one, half dozen of the other. But if we did that, we would have a C in the numerator and a C in the denominator, and I kind of want to, my instinct tells me, that's going to be just a little more complicated, something you can deal with, but having only one instance of C here might be an advantage, okay? So there's your solution for Y. As soon as you get your solution for V, you just take the change of variable, get your solution for Y, okay? Now, Y of 0 equals 1, so 2 over 1 plus C has to equal 1. Very simple equation to solve. Multiply both sides by 1 plus C. You find out that C equals 1. Okay? And that's not even right.
It's not. Because if it's 0 on top of B, then that's 1, and that would be 1 plus 1 at the bottom. And 2
Yeah,
over
but
2.
that's not consistent. That's what we get here, because if B of 0 is 1, C would have to be 1/2. But yeah, then you multiply by 2, numerator, denominator, the same. Okay. But again, you want to look for stuff like that. You want to keep your peripheral vision handy, okay? Because it can show up a mistake. There's a consistency check, right? And you want to do as many consistency checks as you can if you're going to be an engineer and not make things fall down,
Yeah.
blow up, or fail. Okay? Okay. So you want everything to be consistent. You want to check everything 2 or 3 ways. If you're designing something, for example. You want to test it in many ways. There's an analogy here. And I'm not an engineer, okay? You don't want me building things. I'm dangerous, okay? Although my house is still standing. And my deck is more or less getting upgraded to outlast me, okay? Okay, so anyhow, there we have it. So Y and I'll just note that that's 2e to the negative 2t over e to the negative 2t plus 1, which might or might not be an advantage. Okay? If you're taking the limit as t goes to infinity, either form works. It's kind of similar to the kind of solution you get from the logistic equation. We haven't seen that yet, but you're going to see that very soon. So again, you want to be aware of different forms. Okay? But as far as solving the Bernoulli equation, you don't have to rederive wheel here. If you know that you do the change of variable v equals y to the 1 minus n, if you've identified n correctly, you get your change of variable, do the details, and everything turns out. Okay? Now your book actually goes so far as to move this to a formula. Okay? Yeah, pretty good at memorizing formulas, or was. Okay? And I didn't hesitate to do it if I couldn't derive the thing, but use your own judgment about what you think is going to work. Okay? If you use the formula and get it right, and all I ask you to do is solve the equation, fine. If I ask you to work through the details of the change of variable, you want to do that. If I ask you to derive it, you want to do that if you can. If you can't, it's not going to hurt you if your goal is to make a B. Okay? Might not hurt you. It's going to hurt your chances of making an A, but it won't destroy it. Okay? Kind of on that level. If you do everything else impeccably, wonderfully, you can still ace a test before I ask you to derive the equation. Or the solution, the change of variable. Okay, but I at least want you to be able to do this. And if you just resort to memorizing and using a formula, it hurts your chances of making a B. Okay? Again, it doesn't destroy them if everything else is right, and that's the only mistake you make. So just don't make any other mistakes. But that's pretty easy to do. If you just remember to use the 1 minus n and don't exactly remember where it came from. And if you can tell me the premise and just say, I don't want to work through all that, but I know it ends up with this, that wouldn't hurt your chances, wouldn't be too bad. Okay? Or an A, whatever. Okay, got the idea? Okay, very good.